Hi, I'm Ed Carmack. So let's finish up our introduction to ODS reporting by reviewing some key database concepts and terminology. Speaking of terminology, as I was preparing this presentation, I happened to be using an iPhone app called Dragon, which is a voice-to-text converter. It takes dictation and converts it to text. Sometimes what it hears isn't what I meant, because whenever I say ODS, Dragon translates it as odious. And so as far as Dragon is concerned, this is an introduction to odious reporting. That may be the case, but I certainly hope not. Anyway, please remember to set your viewer to full screen so that you can read the slides and print out the handout listed for this topic from the training website if you haven't already done so. We'll be continuing on page 2 of that handout. This list of terms dealing with the hierarchy of data is one that I'm sure many of you are familiar with already, but let's just review it so that we're all on the same page. A database is a collection of files that we will call tables. Each table is a collection of records concerning a single topic, such as courses, students, faculty, and so forth. Tables are often interrelated. For instance, students take courses, so the courses table and the students table are related. A record is a collection of data fields describing a single instance in a table, such as a single student or a single course. A record corresponds to a single row in a table. A record is a collection of data fields, and a data field is a collection of characters, with a character being a single symbol, letter, and digit. A data field is an individual item of information in a record, such as first name, last name, telephone number, and so forth. Data fields are also referred to as data elements or data items. You'll hear me use various terms kind of interchangeably when I'm referring to a data field. In this illustration, the database is characterized by the cylinder because it's a container which holds a number of different files or tables. The tables in this database are named students, courses, advisors, and so forth. An individual table is composed of rows and columns. The columns represent the individual data items, like last name, first name, telephone, address, so forth. The rows represent individual records. Since this is a student table, row 1 would be student 1, row 2 would be student 2, and so forth. Every table has at least one data field that functions as the table's key. The key is a data field that contains a unique value for each record in the table. A table may have multiple keys, but one will be designated as the table's primary key. The person ID is the primary key for the person table. Its value is always unique for each record in that table. So if we want to retrieve a particular person or a particular row, then we specify that person's colleague ID or person ID, and that will always result in only one record being retrieved. We also have the concept of a foreign key, which is a data field in one table that contains the primary key for another table, and we'll see how that's used in examples in the future. And here we see two tables that are related to one another. The ODS person table has the colleague ID, or it's actually just referred to as ID, as its primary key. And the ODS applicants table has the applicant ID as its primary key. Now, although these key data fields have different names, the values stored in them are identical for related records. In other words, these two tables are joined based upon the key fields. In this illustration, the information in the applicants table for applicant ID number 2 pertains to the same individual as that in the person table with a record that has an ID number of 2. So to select information on the same individual from two different tables, we match or join the records based on the key data field. As you can see, the person table contains one record for each individual in the colleague ODS database. In the future, when I say ODS, the ODS database, you'll understand that I also mean the colleague database in most cases, because ODS data is data extracted from colleague. But I'll just say from now on, say the ODS database. So the person table contains one record for each individual in the ODS database, but it contains demographic information only. The applicants table contains one record for each applicant in the ODS, but contains applicant-related information only and doesn't contain any demographic data. So in order to retrieve demographic data for all applicants, or for an applicant, the two tables must be joined so that we retrieve information from matching records only. When joining tables, we must always know how many matching records will be retrieved from Table 2 for each record we select from Table 1, and vice versa. When I say we need to know how many, I mean 0, 1, or more than 1. If it's more than 1, I don't need to know exactly how many. I just need to know that it's more than 1. So in the previous example, between the person table and the applicants table, each record in the person table corresponds to, at most, one matching record in the applicants table. It might not correspond to any, so it would be, the correspondence would be one person record to 0 or 1 applicants record. And that's true because not all individuals in ODS are or have been applicants. There are many individuals in the person table who are faculty or employees that are not students and have never been applicants, and we won't find any record for them in the applicants. Also, for every individual in the applicants table, we must find exactly one matching record in the person table, because we know that every individual anywhere in colleague has to have a person record first before they can have any other information stored in there. So table relationships come in two flavors, one-to-one and one-to-many. The previous example was a one-to-one relationship. An example of tables in a one-to-many relationship might be faculty and courses, where one faculty member could teach more than one course. And so there would be one faculty record in the faculty table, but more than one course record in the courses table. And for each course record, there would only be one corresponding faculty record, because only one faculty member teaches a course. In report writing, the type of a relationship that exists between tables is critical information. A database query is a statement that you write that can be executed by the system and that specifies which data fields you wish to extract from the database tables. A query specifies the data field names you wish to retrieve, the table names that contain the fields, and also how the records are to be joined if more than one table is involved. So here's an example of the kind of thing you'll be learning to do in future lessons. Suppose I want to create a report that lists the applicant's ID, the admissions representative, the first and last names of the applicant, and the gender of all the applicants that we have on file. First, I need to determine the ODS field names and table names that I want to extract. In this case, I want the applicant ID and the admissions representative from the ODS applicants table. And I want the first name, last name, and gender from the ODS students table. I also determine that the records in these two tables are joined based on the ID. And so I look at those two tables and I write down the exact data field name that ODS calls each of those data elements. So I collect that information, and then once I put that query into the system and execute it, this is what the results will look like. And so we see it's in a spreadsheet format. We have columns for applicants, admission, the applicant ID, the admissions representative, the first name, last name, and gender. And all the information on a single row pertains to an individual applicant. We have the applicant's first and last name there, and we have their applicant ID. And for the admissions rep, we only have a number that's listed there. That number happens to be the colleague ID for that particular admissions rep. So we don't know the first name and last name of the admissions representative based on this particular display. We would have had to modify the query to include the first and last name of the admissions rep had we wanted to see that. So it's critical that we know exactly what data is stored in each of these data fields so that we get on the report that information that we were actually looking for. So this data then can be easily saved to an Excel spreadsheet on your computer, and then you can use Excel to do any further summarizing or formatting that you choose. You can also use, in addition to Excel, you could use Access or any other software tool that will use Excel data as an input. So in future lessons, we're going to focus on query writing and the use of specific report writing tools like Excel and Access and others as needed.